Hey everybody, welcome back to the channel. Today I wanted to talk about two reasons why reinforcement learning in trading is so difficult. There's probably more reasons, but these are the two that I found in pondering upon the subject, the two things that I found were the most relevant. Both of these sort of fit under the umbrella of a limited data observation space. If you've been following my channel at any length or have tried to build your own agent, you may have encountered this sort of conundrum before. It's really hard to get a reinforcement learning agent to um, actually, at least, if not just beat the market, at least do as well as the market, right? So these are the only strategies that I've ever been able to accomplish were models that could at least keep up with the market. But in those cases, it's just a lot safer to just buy and hold something or just use a more conventional trading strategy. Reinforcement learning is like typically a good method to use if one, you're trying to extract new strategies from something. My favorite example of this is using AlphaZero, built by DeepMind, that is a chess agent and it also played Go, where it takes and it does actions that us as humans wouldn't normally take, but because it's able to play the game and learn the game at an infinite scale that we couldn't do in our lifetime, it can extract new strategies from playing that game. Or reinforcement learning is really good for, say, you want to teach a robot to do a simple task. So Amazon has robots that search out an item in an inventory warehouse, pluck that item, and bring it back somewhere else. That's another really good use for a reinforcement learning type method. And so you would think that with trading, this would also be a good method because trading is kind of like a game and you're trying to use the agent to create new strategies that might have an advantage in the market that we as humans otherwise wouldn't be able to calculate in real time. So you would think that it's a good strategy, but I think there comes into two issues with this kind of thinking and with this kind of approach to reinforcement learning trading. So the first reason comes down to just limited data in iterations. In most cases, reinforcement learning has an unlimited amount of, I guess, attempts inside of an environment to learn the actions that it needs to learn. So if we consider the AlphaZero by DeepMind example again, it can play in pretty much an infinite number of chess games, just over and over and over again. And different actions that it takes within that game will have an influence on how close it gets to its reward. Where it differs here is that it's not trying to place a buy or a sell order at the right time. The agent in a trading environment has no influence on the next input bar, has no influence on the close or anything else like that. Its only influence is whether it will place a buy or a sell at the right time, versus a reinforcement learning agent inside of a game, for example, where it can actually influence the next state space observation. And we can think of other examples, like consider reinforcement learning agents that play Gran Turismo or Mario or StarCraft. I think these agents, even what they're able to do with their state space is that they're able to make mistakes and then start over, and the course doesn't change. The level doesn't change. I mean, it all sort of runs exactly how it should be. Like a Gran Turismo course, the course is going to be the same loop over and over again. And so if you're trying to teach a game to play Gran Turismo on one track, for instance, the more it plays that track, the better it will get. If you're playing a Mario level, it just needs to keep playing that level over and over again until it can beat the level, the same way that humans do. But if you apply the same kind of interaction in the trading environment, it's like you're reliving the same day over and over again, and it just doesn't really work that way. So if it's not optimized to begin with and it runs through the data, then that's it. You either train it on data that it's already seen before so that it gets really good at that day, and in which case you're not creating a very good model. You're just overfitting it for that one day. One alternative approach I've considered to getting around this problem is to stream data through the model as it's training. So take an FX WebSocket or a crypto WebSocket and push it through the data, or push it through the model, I mean, so that it has an infinite amount of learning steps across multiple days and hours. But this might take forever, because if you think about it, I could just download like years worth of 1 minute tick data from somewhere. I might have to pay for it or whatnot. I'm just sort of thinking hypothetically here. And then you could still test it. You could still have the same effect without having to stream it. So I don't really know if that would work or not, but you would kind of just need to keep training the agent until it hit a loss function that was really good, and then you would stop the training there, and then you would test it on new data to see if it actually can do anything. This problem is more along like a self-driving car, but even a self-driving car, it has its own issues, but it just needs to observe the environment in front of it. And you could at least start with a car in different environments. So you could at least train it to park first, and then you take that model and then you train it to exit the parking lot and merge onto the road, right? So you can just do the same iterations over and over again, or the same kinds of small tasks over and over again, to sort of generalize its ability for new environments that it sees. And I think this might be the case for trading and reinforcement learning. So you'd have to be, I think part of what needs to happen is to isolate down to specific things that you'll see within the market. And just as a side note, I don't have this in my notes at all, but as I'm talking about it, the more I'm realizing that with self-driving cars or with reinforcement learning and trading, the big thing that you're doing is really just trying to automate a system to put in the buys and sells for you. You're automating, for self-driving cars, you're automating the driving. Essentially, you're automating the decision or cognitive upload that you would need to drive. So this is more of an automated task more than it is trying to achieve a goal or an outcome per se that you could do better or worse at. So it's sort of just like an interesting, different take on the use of reinforcement learning. This sort of brings us to the second point that I want to make, which is an unclear space dimension. So when I mean space, I'm talking about the environment that the agent is training within. So it's called gym for a reason, and it's because it's supposed to be a gymnasium for your agent to explore and make mistakes and make corrective actions and continue over and over to build up its abilities. And there are large differences between a trading gym and a traditional gym that you would use for robotics or something like this. So again, if we take an example of our chess Alpha 0 example, the observable state space that it's going to be is the chessboard and any pieces on the chessboard. And every game is always going to be in a dimension of a chessboard. So if you were to set out to build a reinforcement learning agent to play chess, your state space is really well defined. Same with the other examples I've given, like your race car track It's going to be the same track over and over again, or it might be a different track over and over again until it can drive that track. With trading, it's different because I mean, you would assume you would want price. That's the given, I think. But do you need high open, low, close volume? Do you need Bollinger Bands? How many technical indicators do you need? Do you need macro indicators? Do you need a lot of indicators and a lot of dimensions? Because I've trained models on open, high, low, close, and I've trained models with open, high, low, close, and then like 15 other technical indicators, and have come out with the same results for either one. So it's really up to the engineer to decide what the environment is going to look like, and deciding how valuable a technical indicator might be compared to something else is really difficult. And I think, especially in the beginning, people tend to trivialize, if you just give it a macro indicator, or if you just somehow model real world events and model sentiment analysis, that will be the key indicator that pushes your model into having an edge in the market. But I don't think that's the case in this instance. I think because there's not a clear sense of, because there's lots of different strategies in the market one can take to make money, I think the model struggles to automate any one particular strategy when it's learning. So I think this particular exponentially complex dimensional space that you can build, or just a very narrow space that you need to build, makes training a model a lot more difficult, because there are less constraints on what the engineer needs to take into account. And so in some instance, what I'm trying to say here is that the constraints in other use cases for reinforcement learning actually make it more feasible to use reinforcement learning. Whereas if you have an infinite number of space dimensions that you can put to the model, it actually makes things more complex. And so it's really up to the engineer to figure that out, which is actually incredibly hard. And then finally, a gym is typically like a geometric static space, whereas a market is a fluctuating time series space. So I think the fact that it's time series, and I've touched on this already, I think because of this also makes it really a difficult gym to create and model for an agent to learn within. I'll just finally kind of wrap up this video by just reiterating my point. If you're going to train a model, or if you're going to train a robot to walk across different topographies, you might start with like a flat surface, and then you might train, and then once it can walk on a flat surface, you might give it inclines and declines. You might make it bumpy, you might make it wavy, you might do all sorts of different topographies, and you wouldn't move on to the next one until it's mastered an easier variation. With trading, I don't know if that's possible. I don't know if you just train it to do a momentum strategy until it got that down. In which case, are you really doing reinforcement learning at that point? Anyway, I hope you enjoyed this video, and I hope it at least has given somewhat of a framework of the problems with the state space in trading for reinforcement learning that one needs to address if they want to begin building a model for reinforcement learning. These are things that I think about, and ways that I'm trying to think of how to get around, or how to solve. So let me know in the comments, are there things that you think I'm wrong here on, or do you have any suggestions on how I might be able to make the state space for training the model more efficient or more manageable? Yeah, and I'll see you in the next video. Take care. Bye.